All right, so we are in class on February 25th. This is the last class of the day. We're 1 week into sprint 2. So, sprint 1, most of people have submitted. Definitely there was a rise from the last week. So, we have some people who submit a week late. You'll get a penalty, but at least you submitted. If you haven't submitted, um, we're now 2 weeks in, but it's still better. Like, just come to lab time and wrap it up. Work with us. We have like over, I don't know, like 8 hours of lab time. Just come and wrap up the project. The issue, that happens if you haven't submitted yet, is that you spend your work time that week finishing up sprint 1, but you're not listening to me. You're not following along with the lecture. You're not learning the new material. So as you like make up old work, you're falling behind on current work, and then you kind of continue that cycle throughout the rest of the class. So we have 4 sprints plus a final. That's why I had one sprint like 3 weeks in. Just do it, like, so you understand what the cycle is, what the amount of work is. That gets you regulated for the rest of the semester. So if you're behind, just come in Monday, Wednesday, Thursday. If those times don't work, just contact me. We'll find a time that works. The TA did the grading. The policy was your project description is just like a paragraph long. You just give a description. Even if you're following more or less with what I'm doing, just write the description. It's okay if it was close to what I did. Then get your user flow out. So in that case, you play with my demo. You read through my project description. You redo your project description. The user flow is going to be different because your thought process of what you think is happening or how the tools should work or the feature should work will start to deviate from mine. So it's okay to read through mine, use it as an example, but you can't just copy and paste my user flow back to me. If you did, you got a bad grade. User flows are your first step to you originally describing your code, your features, your ideas. So you have to do them yourself. Once you create your user features, you build the project, you code it up, you build it, submit it, zip it up, you get it onto HIO, you post up the link. That's everything I need for sprint 1, and all the sprints are going to be the same. It's just new features. You can modify and enhance existing features, or you can create new ones. You can even go off and do something else. I'm going to get into in a moment, but I'm going to want 5 features. I'm going to show you what I'm building. You can follow along with me and modify off of it, or you can come up with a few features yourself, or you can try something else. But if you haven't submitted for sprint 1, come in to lab time. If you need help defining your ideas for sprint 2, come into lab time. If you have new ideas for sprint 2, iterating off of me or something brand new that you have an interesting idea about, come in for lab time and we'll work through your ideas. The end result is we should be wrapped up with sprint 1, 20% of your grade. We are now 1 week into sprint 2. We are here. We have a work a week, another week of work, another week of work, another week of work. We have 3 out of 4 left to complete before spring break. I have the drop for sprint 2 at the end of spring break. But basically 4 weeks of work. We're 1 week in. And to make it easy on yourself, if you want your spring break time, just drop the project before spring break. Else you have till the end of spring break. But use spring break to get caught up then, because we're going to move into sprint 3, sprint 4, final exam, and then we're done. The TA did the grading for sprint 1 based on the guidelines I just gave you about the user flows and your builds. So if you have questions about your grades, come see me. He also gave comments on them. Some people are already starting to do some really interesting, cool stuff. Feel free to experiment. And is there any questions on that kind of larger structure of the class, where we are, where we're going? All right. So I just, this is what the sprint 1 user flows look like. I started to create the online videos on the weekend. I wanted to try and get a little ahead, see if I can release them earlier. So basically, I just put a box around and put a title on the Sprint 1, and I'm using the same document. Over here is Sprint 2. So I'm going to go over the basics of how I'm starting to create these, and the online videos go into more depth of, because we haven't touched the diagramming tools in a few weeks, and I go over, just refresh how to use them, and also my thought processes on creating these Sprint 2 features. I'll also, hopefully, in this week, I'll finish up my demo app. It's still being built. I'm going to connect the sun system to the clock, and hopefully have like the paint strokes do something different at different times of the day. So I mean, it's like you can create your own little virtual environment. That's your little painting environment. So user customization, and express all these features out into the user interface. And hopefully I can get the demo app up, and get the posting up. I will go through how my posting. So I'll make my project description. I'll show how to export out. Someone had questions on like, how do I export images out of the diagramming tool? I'll go through uploading to itch.io again, and now I also found you can embed the code directly in your posting, so that the build will just run right in your posting. You don't have to provide a link anymore. And I'll do my own posting to make sure you understand what's expected for Sprint 2. The major deviation maybe is that I'm not going to be giving you suggested work per week. So Sprint 1, it was all brand new. I said, hey, look, at 3 weeks, you're going to give me something. I'm going to give you a grade. So I suggest you do this week. I suggest you do that. I suggest you do this to make it easier to regulate your time to build this demo. I'm not going to be doing that for the rest of the sprints. I'm going to be building my demo app. You follow along with me, or you try your own features, get your new ideas. But you know that in 4 weeks' time, or what have you, the Sprint 2 do, and then we do it again for 3 and again for 4. And you can build and on an existing idea and keep adding new features, or you can try something for each sprint. It doesn't matter. In this case, I want you to do 5 features. Now, I've got 4 listed. I'm going to go over how I made these 4. But I have 4. I'm asking you for 5. So at least one I know you're going to have to come up with. Now, you'll notice in Sprint 2, I've started to like organize it a little bit. So you don't have to do this. But what happened was I started writing out my features. I didn't know. I'm just building this app as we're moving along. So I have like this size scale. I got this clear button. I got like left click to delete an individual object. I'm starting to build out some more features. So I started writing them out. So I found out as I was writing out all these features, I was able to kind of group them. So one area was kind of like destruction or clearing. One area was like stroke modification. So you saw how I was like morphing the objects based on how fast my paint stroke is, so it feels more like they're filling out the space. And then I have this idea of environment, or changing the sun, the time, maybe even the paint strokes with that. So I was like, oh, I can kind of group them. So you can see here, I have my features kind of grouped in these feature sets. One is about paint object clearing functionality. One's about paint stroke functionality. One's about the environment functionality. And when I wrote them all out, I almost had I had 8 features. And as I started to build them, or build the diagrams, I noticed that they were super simple. So, for example, like just changing the size, like this, dragging this size slider allows you to change like how big your range is of just dropping an object down. That's this one right here. And it's only this size. So at this decision point, if you're messing around with the size, change the size, right? So all of a sudden I started making all these features, and they're all like really simple. There's like no decision points. They're like 4 or 5 nodes of a size. and a lot of the information is being replicated. Like, for example, if I broke this out into two user flows, one for messing around with the actual size of a stroke and one for messing around kind of the non-uniform scaling to read back where was the last one and morph or the distance between the objects, how that should influence its scale. I mean, all this before it, like the queuing the user for input based on paint stroke, starting out the input that's happening. It's I was getting like an information bloat. It was just like all this like horizontal information of user flows, but a lot of the information was replicated. So I started to condense them. So I went from like 8 or 1, 2, 3, 4, 5, 6, about 7. No, on slider, on button. Yeah, they all have like 2. So I started with 8 and I condensed them down to 4. So this is about when you develop your features and you're diagramming them out and you're like, is this a substance enough, a large enough feature to work on? This is the depth, the complexity of each feature I'd like you to aim for. So as I look at Sprint 1, they're of kind of similar complexity. There's no more nodes in this, and there's not less. So these are about of the complexity that's good enough to pick 5 features that you can work on. And if you have more questions, again, just come into Loud Time. So here in my clearing functionality, I took everything that had to deal with input clearing. So I have this idea of you can left click on objects to delete them individually. And I have this idea you have this kind of like clear all button, this delete all button that deletes everything. So to me, that was like user input deletion. And then we have timer-based deletion. So this idea of you can turn timer-based destruction on or off for future paint strokes, and you can adjust how long the timer is with a slider. So those two, they both had to deal with timer-based. The overlap was too much. I morphed them, pushed them into one feature. So input-based deletion. We have a start period. We have a queue the user. So we have to give them directions. Be like, you are able to left-click on an object to delete it. We have to inform them what they're able to do. And we give them a button that's labeled properly. Let them know if you want to clear everything, you can delete it all. So then a user input event happens. He clicks or drags. And did he click on an existing collider? If so, he meant to delete one object. So the process that we do is we delete an object, and then we end the flow. So even if he's left dragging and he's deleting many objects really quickly, we can actually boil it down to he's just going through that one user flow just really quickly over again to delete many objects. So I don't need to make it more complicated. Just repeat the user flow. And if he did not click on a collider, well, the only thing within this flow that makes sense is where we have the clear button made available to him. So that means he must have clicked on the clear button. And if he did, that means we should delete everything, not just the one object that we're trying to find. So this is one feature, timer-based. We start. We're in one discrete section feature of our app. Queue the user. So we give a toggle available to enable, disable the timer. And we provide a slider for manipulating the length of time for destruction. An input event happens. What did he interact with? The user interacted with the slider. Then we changed the time to clear on future paint objects. If he interacted with the toggle, well, then we have to do a check. Was that toggle enabled or not? So if the toggle was enabled, he clicked on it, meaning he wanted to disable it. So the check mark on the toggle should turn off. And we should disable timed clear on future painted objects. If the toggle is already turned off, that means he wanted to turn it on. So timed destroy should be enabled for future paint objects. Either case, we end the cycle. We end that user flow. All right. paint stroke modifications. So we cue the user for input, give a slider to change the size, and then I still have to add some user interface elements for this idea of distance or non-uniform scaling based on how quickly the user's moving the mouse. So what I'm thinking is this area here still needs to be changed. I think I'm going to enable and disable that feature. Sometimes maybe the user wants that, maybe sometimes they don't. And if they do want it, maybe I'll allow them to manipulate how strong that effect is. And all that really means is deep down here, we're just manipulating or exposing these variables that are extending, pushing this sphere on the X and the Y, how much we're scaling them based on the previous stroke. And the painting environment. So I'm going to update the user interface. You kind of saw how I was sliding from 0 to 24. There's 24 hours in a day, and it was changing the sun setting. And then like an option or a button to go back to the current system time or let you change it. Now I'm going to do it that way, but you don't have to. You can think of like a drop down. So maybe you don't want the user to pick 24 hours, each of the 24 hours. Maybe it makes sense to say, hey, I want a setting for dawn, high noon, dusk, and evening. And so the user just has a drop down, and you set the time, and maybe there's some other effects, maybe some sound effects, or some clouds are moving, or whatever, some stars come out in the sky. I'm just moving the sun though. What I think I might get to is somebody in the previous class wants to drag on the hour hand of the clock to update the time. So I like that idea because then it can remove a user interface element for me. I don't need a slider or a drop down. It lets me, my user interface is already getting cluttered. It's already taken up quite a bit of the screen real estate. I'm going to have to reorganize it and try to shrink it down anyway. So anything I can do to minimize it, simplify it, make it look good and crisp, clean to the user is a benefit. So I probably will make this clock, since it's sitting there as this passive object in my interface, even though it's a 3D object, I'll probably make it interactable and somehow make the user realize that he can hover over it and drag the hour hand. I did realize as I was clicking in the previous class that there's colliders on this thing, and so I have the functionality of destroying stuff if they have a collider. So I have to deal with the fact that I should only be destroying painted strokes, not other objects that need colliders, because I'm going to eventually drag the hour hand. So anyway, that's the essence of my user flow. This is where I'm going for Sprint 2. This is what I'm going to be talking about, doing videos about, building functionality, user interfaces, and you'll be following along and doing something for yourself. Is there any questions? All right, I think I covered all the overhead in the class so far. Now, how many of you were able to go through and actually build your clock? All right. So there's about the same percentage in the other classes. So people had issues. They got stuck at certain points. He wants to show you another way. Yeah. So it's his way of kind of teaching you a little bit some of the concepts of CS through changing stuff. So I'm going to go through this tutorial. We have it takes about 50 minutes from the other classes. So for the rest of the class, I'm going to go through building the clock, go through some common issues, misconceptions, obstacles. So if you have any questions or areas that you got stuck, you just let me know. We talk about it. And then at the end of class, we just kind of repeat. If you make sure you understand that you are currently in the middle of, at the beginning, middle of sprint 2, and you need to be dropping something at March 24th at the latest. Okay, so I'm going to hide my clock. I've got previous clocks I've been creating in the other classes. I'm just going to delete them. So this is his tutorial. He starts off with modifying the Windows layout. Mine is set up like this because I'm going to have to share half my screen as I show it to you, so I found it's easiest to set up this type of layout. But you can grab these tabs. They are currently in a dock state. You can pull them out and call what's a floating state. They're a separate little window. You can right click and delete them. If you ever delete them, you can go back and try to find them and respawn them. If you really mess up your layout and you don't know what to do, just go to layouts here and click default to reset it, or he's using 2x3 if you care to follow along with that layout. If you end up overwriting a layout and you try to go back to it and it's giving you this messed up state that you saved out by accident, just revert factory settings. All right. So he goes into creating a game object. So game object, I'm going to, before I go forward with empty, I'm just going to create a game object that has something visual on it. I'm going to create a sphere. So by default, the position is this random information. It does this because if you're quickly spawning stuff, it doesn't want it to be sitting on top of each other. Just get in the habit of resetting that position to 0, 0, 0. And if your camera is set up correctly, or something similar to this, then you should be looking directly at world space 0, 0, 0. And the reason we do that is it's very easy to like place stuff. It's very easy to, as you'll see, do math on rotation and position when we're at a 0, 0, 0 world space. So to do that, your camera should be something like this. The rotation should be zeroed out. It should just have like a -10 on the Z. So it's just pushed off of world space 0 and it's looking directly at world space 0. So as I have this, created this sphere, and if I just enlarge it a little bit, you see that this is my scene view, this is my game view. We are actually looking at it. So this is your first step toward diagnosing if you're having issues finding stuff in your scene. Make sure your camera is positioned right so it's looking at world space 0. If the object does happen to be way off somewhere else and you can't find it, you can click on it, press the F key in the scene view to kind of find it. You can zoom out, press the F key on the camera. This is what that little icon looks like. These lines are like the fulcrum. This is like the volume of space that we're looking into through the camera. So the object needs to be in that volume of space. I think I just flipped the camera upside down, the view upside down, so it got confusing. Notice how the object is not in that fulcrum, it's way off here on the side. Notice how the user interface is really big and off to the side. That's because we're doing the screen space, where it's just rendered directly into screen space. It's not, we're not considering where its world space was. We went over the difference between screen space and world space. The sphere, though, is a 3D object exists in world space. We do have to be aware of its position relative to the camera. So either if you make sure your camera is set correctly and zero out the position of your object, then you should be able to see it. Or if that's not the case, you could always drag the object and make it a child of the camera. Children will inherit the position, rotation, and scaling information. So if we zero out the position of the sphere, it's going to sit right wherever the camera is. So even though that position information on the sphere says 0, 0, 0, that's its local position, not its global. So you see that the parent is 10 units negative in the Z, and that's actually where the sphere is sitting as well, but we don't even need to know that information. It's just zeroed out sitting there. So we're going to take advantage of this fact with this clock, with all this rotation that needs to happen. But just know that once I put the object as a child, zero it out. You can just move it in the Z to find where you want it in front of the camera. And then you can even pull it out from the camera, and its information will be updated. Really push it off in the Z. So these are ways to figure out and find your objects in the scene. As I was moving this object in and out of being a child, notice what it looks like visually in the hierarchy to be a child. Notice as I click and drag, the icon looks different. So when it's this line with a dot, this is going to place it not within any object, just in between the two in an ordered list in the hierarchy. If it does get this type of like highlight around an object, this means we're going to place it within it. We're going to make it a child. All right, so I'm going to do game object create empty, and we're going to call it clock. And notice its position. Yeah, I'm going to reset that so it's world space 0. And this is going to act as our like parent, our holder. It's important that it's zeroed out so it's easy to deal with the rotation later on. So now we're going to create the face of the clock. We're going to create a cylinder. And it's going to tell us to, I'm going to get rid of the collider later. I'm going to show you why he wants to get rid of the collider first. So we have a renderer part of the game object, and we have a collider part. The collider connects to the physics system. It's useful if you want to deal with user input, if we're clicking on something, or later on if you want stuff to bump into each other and actually be like active physics objects that respond to each other. For now, he's saying take the transform and change the scaling information of this. So I'm going to reset the position. I'm going to click on scale X, update X to what he wants, press tab to jump to Y, 0.1, tab again to Z. And now the object is like a flat, it's like a coin. This is going to be our clock face. He actually wants you to rename it to face. Now notice this green, these like two circles. This is the actual collider. So the collider is actually more of a basic piece of geometry. And it doesn't allow for such modifications as the mesh that's used for rendering. The reason for that is that physics is really expensive, and you need to use very simplified geometry. So when you have complicated objects, you might have multiple colliders like capsules and spheres and cubes positioned around this larger object, used for whatever the physics interaction that's needed, but you're not going to have very complicated geometry for its colliders. So when we scale it down, the collider looks weird because it doesn't have the shape to mush down like that. So that's why he says get rid of it. We're not actually going to use it. We're not clicking on the clock face. The clock face isn't interacting with any other physics objects, so it doesn't need to have a collider on it. All right, so the face and the clock, and then he wants to make it the face a child. So we drag it underneath the clock. Since the clock is at zeroed out world space and the clock and the face, it's actually in the camera view. We just don't see it because it's pointed up right now. But if I messed around with the rotation, and it looks like an X rotation of -90 or 90 faces the camera. Once we start building objects on top of it, we'll see what's the correct rotation. But just note that this is in front of the camera. What's a common situation I saw with some of the prefabs that people were creating is that the parent was like way off somewhere else, and the child was moved to be at World Space Center. So even if this object looks like it's sitting at World Space Center 0, and if I rotate it, you can see it. Notice how the local X position had to be offset from the parent's X position. So if you were to like spawn stuff like this is why a lot of you, when you're spawning your prefabs, they were just like all over the place. You couldn't even find them. Your parent, it's very important that they are zeroed out. And then your child can be, so if I duplicate this, and say if there's a few objects that need to be created to make your prefab, I can relatively offset them small amounts around whatever world space center is, and then when you take that parent object and you rotate it, they're all rotating around that center point. Everything is clean. And when you spawn it, it spawns wherever you wish to spawn it because the parent is zeroed out. There's no additional transform information. So I'm going to delete the rest of these faces. And my parent is zeroed out. There's a little bit of rotation left on there. I'll get rid of that. All right. So now we're going to create the hour indicators that go around the clock face. So we're going to do 3D object, create a cube. Looks like he wants to call it hour indicator. And here's the information. So I'm going to start up at position X, 0, tab, 0.2, tab 4. I can tab right through rotation, get to scaling 0.5, 0.2, and 1. So if I press the F key, we see that he was positioned at the top of the clock face, like our 12 o'clock spot. And we're going to create a material. So my project and my hierarchy are in the same little pane. So I'm going to jump over to project. You should have a materials folder created. I'm going to right click, create material. I've done this a few times, so I'm going to call it clock dark 03. I'm going to open up the color pane on it. And he's saying change red, green, blue to 73. Now the reason he's saying that is I was training you in RGB 0 to 1 because that's how you're going to morph it with code. But he's using the standard 0 to 255. The behind the scenes, there are 256 values per red, green, and blue. And so when he's saying move your RGB down to 73, it's actually 73 out of 256. So if I switch it over to what you would be doing if you do this with code, it's actually like 0.28% to 1. So it's a pretty low value. So a dark gray he's talking about. So once I create that, I'm going to drag it on, and I can pick the object I want to put the material on. And so I wish to put it on the little hour indicator. Yep. Okay, so now we're going to start to figure out how to start placing these around. So I could jump back to hierarchy. I could take this hour indicator. I could duplicate it, Control D, and start to figure out the position and the rotation that each segment need to be. But I'm not going to be precise, and this is way more painful than it needs to be. We could do a little math to figure out the location for each. But notice that we do need to change their position and their rotation. So we're going to move these around a circle. The circle is 360 degrees. We have 12 units, 12 sections. So we are dealing with 24 hours of time, but the clock is 12 hours. So 2 cycles of the clock for 1 day. So if we're dealing with 12 sections, 360 degrees, we do 360 divided by 12, and we figure out each need to be moved 30 degrees. So we can mess around with the different rotations to see which one makes sense. Not that one, not that one. And we see, okay, it is the Y rotation that we need to manipulate. But notice how as I'm rotating it, if I move this 30 degrees, that doesn't solve my problem. It's rotating around its center. It's like the Earth rotating around itself. That only gives me one part of my information. I need the position. So we can create a game object, zero out its position so that it's sitting at the center of our clock. The clock's sitting at the center of our world. Drag the hour indicator underneath it, make it a child. And if we click the parent, notice the gizmo is at the center of the clock, not the center of the object. And as we rotate the parent, it's sliding this hour indicator around the face exactly where we need it to be. It's moving, it's actually updating both the position and the rotation of this hour indicator. But if I click on the hour indicator, notice that its position and rotation is the same. So this position information was when we defaulted it. So if I zero this out, this is what the default information for our hour indicator looks like. And as I rotate this game object into different places, and I click back to the hour indicator, it's the same. Let me just undo that because I want to keep that one there. Let me duplicate this whole thing, move it 30 degrees, and now my second hour indicator, which is going to act as my 1 p.m. or 1 a.m., is now into position. And if I pull it out of its parent game object, notice that its information got updated. Its X position changed, not its Y, because they happen to be at the same Y level. The Z position changed, and its rotation on the Y changed. So all that information was figured out for us on the fly because of this parent-child relationship. So we didn't have to figure out all that additional math because we took advantage of this parent-child relationship, very similar to like the Earth revolving or orbiting around the sun. Its position is changing if we were to say that, if we were to base a coordinate system off the location of the sun. So I'm not there yet. I just want you to see that I'm going to put it back in its parent. I'm going to start building out the clock face. But I want you to see the difference between its global information, global position, global rotation against its local. And when you parent stuff, you can take advantage of simplifying the numbers, simplifying the mathematics, having a different pivot point to rotate upon, to either build stuff out, keep track of stuff, animate stuff. Now this last one is at 330 degrees. I don't need the one at 360 because 360 is the same as 0. In fact, even 720 or 2 cycles around the clock is the same as 0 degrees. So once we create all our hour indicators, he asks you to open up all these groups, all these parent groups, and get all the indicators out of them. So we don't need that information anymore. We don't need that overhead of additional game objects. If we did make sense to move this thing, if you wish to have your clock face like animate and build these out in real time, then you would probably want to keep this structure. But I'm going to pull them out. And notice as I move through them, how both the rotation and the position information is changed at the because they're now looking at the global level of them. We're looking at all these objects have different positions and rotations, and they're all like siblings to each other right now. You can notice that the rotation goes up to 180 and then starts going negative. So something like, first off, a negative 180 is the same as 180. Negative 90 is the same as 270. It's just internally, Unity likes to work with this kind of flipped negative structure. It still means the same thing. So I'm going to go and delete their parents, and we have a structure like this now. Any questions so far? Still recording. So we did all that. We deleted everything. We organized it. You can talk a little bit about floating point errors if you wish to look in there more. So creating the arms. So we're going to create another cube. We're going to update its position. Since we're going through updating all the position anyway, I'm not going to bother resetting it. Now we have some scaling information we're going to put in. And we're going to put a material on it. All right. And go back to the hierarchy. And if we rotate it, we see it's still rotating about center point. So to fix that, we're going to have to go ahead and make a parent. This time it's quicker to just zero out the rotations. We're going to call our position, I should say. We're going to call it hours arm. Call this arm. Make it a child. Bring the whole thing. Right now it's not within the clock structure. So I'm going to bring it in. And if I rotate at the parent, it's going to look like that. I'm going to minimize my game view because we're not really using it right now. Just going to look at the scene view. So this works well. All right, and it wants me to duplicate this out twice. One for minutes. One for seconds. And it wants me to change the minutes scale to, I know I have to go in to be careful here. It wants to change the geometry, not the parent, which is just there for rotation. I have to go in, change this to 0.2, 0.15, and 4. And then change its position to 0.375 and 1. All right, so it's a little bit skinnier and longer. It's got more of a back point to it. And if I rotate it, it works. And the material is as it is. And the seconds, we're going to go to 0.1, 0.1, 5, 0.5, 1.25. And we need a new material for that. I already have a red material. I'm just going to reuse that. And I can test it. So they're all sitting on each other. Everything's clean. Test the rotation. It looks good. All right. Then he said you did all this work. Make sure to save your scene out. So save often. You don't want to lose work. Here's the Unity package up to this point. So now we're going to animate the clock with code. So we have to create a script. I already have a folder here. Create another clock script. All right, go back to the hierarchy here. I'm going to minimize my clock group. I'm going to add a component. If you just search, I'm going to search for clock. Here's my clock script. So I'm going to attach the third one. I'm going to open it. So he shows you that this is what the script looks like at default, and then he deletes it all and he builds it from scratch. So he talks about what a class is. He talks about the public modifier. You can open these up, read more about the CS fundamentals. Talks about the fact that a class or any block of code needs to start and end with curly brackets. He talks about the fact that we're going to inherit. Oops. We're going to inherit from mono behavior. So this is the inheritance sign. That mono behavior is a class from the Unity Engine library. So we don't have a using statement at this point. So we have to specifically say, okay, compiler, I need to use this class mono behavior it's in the Unity Engine library. So if you say Unity Engine dot monobehavior library dot class or namespace dot class, you'll be able to access it. But since we use a lot of Unity Engine classes, it's not worth doing that everywhere you're going to use mono behavior or update or start or anything else that's inheriting from Unity Engine. So just say using Unity Engine at the top, and then you can just say, well, I'm using this class mono behavior. And so the compiler knows to search in this namespace for it, and it happens to be there. So once we do that, that script is now a mono behavior. It is now a component. It can be connected to our game object. And so the script kind of looks like this right now. I'll get rid of my update start. I'll move my opening curly bracket down so it's easier to see the start of my class. And now we want to know about our hour hand, and we're going to move it with code. Okay. So we've done before. We've done references. We've done public game object references to other game objects or prefabs. And then if we've ever wanted to morph something or mess around with the transform or something, either the position, rotation, or the scale, we've gotten a reference to a game object, and then we're able to jump down and find its transform with get component. So we've done dot transform, which is shorthand for saying get component of type, and then you specify transform. And then we've grabbed other components. We've grabbed scripts this way. But since we know that we're just messing around with the transform, we don't need to connect a reference to the game object and then in our code have to specifically say get component transform, go find that for me, and then we're going to mess around with the transform. We can actually just make a variable or a reference of type transform so that when we connect it, it connects directly to the component transform and not at one level up at the game object. So we're going to add this public transform hours transform, save it, let the script compile. Oops, sorry, I got to pop up the clock. Okay, so now we have a reference, a public link. Okay, so who is this hours transform? So I'm going to drag this down and say this is the transform component because we're going to mess around with the rotation that we wish to have access to. So once we do all the connecting, the author is saying that we also need to know about the minutes transform and the seconds transform. And we can list them out as separate lines, writing out the complete type of variable and the accessor, but you can do a shorthand if we're listing out or declaring multiple variables of the same type, same accessor, that you could just put them all on one line like this. All right, I'll save that. Let it compile. And now I can specify. So my order of objects is a little out of place. So I'm going to drag these two up. So we have hours, minutes, seconds, and then I can connect them. Awesome. So these are the three transforms I'm going to interact with. So now we're going to start to figure out how to read in the time. So he creates this awake function. It's very similar to the start function. So you've been made aware of the start function. So whenever an instance of this class, which is connected as a component onto a game object, for example here, whenever we click play or whenever this app is run, this game object exists at runtime, so it gets created right away. All of its components get created. When a component or a script gets created, it runs its start method once. Then from then on, it just runs its update loop every frame. The awake is another one. So once a component is created, it is then enabled. So just like game objects can be disabled and enabled, the same can be done for its components. I need to find a script that, so for example, like this. So they still exist, it just can be enabled and disabled. So when it's disabled and then enabled again, that awake method is called. So awake can be called multiple times in this situation if it's needed. In this case, we're creating and enabling this component once, and so this awake function is called once. You could have done this in either the start or awake. Then he goes over what's public and private, and he puts in this debug log. We've done this before. It just prints a statement to the console. Here he changes the debug statement to be time.time. That is the time that has been allotted since the actual app has run. So when we run this and this awake function is run right away, it's going to print out 0. It's because this function has been run right when the application started, and it's been 0 seconds since the app started. If this game object is instantiated later on, say if it's instantiated a minute into runtime, this awake function, this debug in it, would print out 60 or 60 seconds into runtime. So now that we've talked about the time of an application, we're going to talk about the system time, something that exists outside the app. So our OS is taking care of what the current time is. We can grab that by saying the using statement system, which is different than these other using statements. Systems.collections and generic are referencing different libraries of code. So the system library has access to the date and the time information. So if we change it to date, time, and now, I'm just going to take this whole function. So if we run this, this is just datetime.now. Datetime is a struct that has a lot of information connected to it. Here we see in a form that we're used to the date and the time. So if we dig a little deeper and say, I don't want everything from now, I just want the hour, save that out. Prints out 15, or the 24-hour format of 3 p.m. So now we can grab the hours in a 24-hour cycle and make use of that information. So we can use that to rotate the arms. So in the 24 hours of a day, we know that we're going to get from 0 to 24, probably 0 to 23.59, but whether it reads in 0, 12, or 24, we know that it'll still be pointed in degree 0. So if we say there's 12 hours and 360 degrees, we have 30 degrees per hour. So whether we feed in hour 12, 0, or 24, which comes out to degree 0, 360, or 720, we know that it'll still come out that the hour will still point up. So we're going to use this quaternion method. You should have been used to quaternion when we said quaternion.identity when we had to instantiate stuff, which means shorthand for saying rotation of 0, 0, 0. Quaternions are math structures that we're going to have to use for rotations. It gets complicated behind the scenes. We can't just give rotations of x, y, z. But we can use quaternion.Euler to feed in rotations of x, y, z that we're familiar with. And then behind the scenes, that gets that gets converted over to the math for quaternions. So if you use quaternion.Euler, Euler angles are what you are familiar with. That's 0 to 360 degrees per full rotation of a circle. We can now feed in x, y, and z, very similar to vector 3 for positions. So we're going to feed in that hour information. We're going to multiply it by degrees per hour, which we have to create the float for it. And we've already done the math. 360 divided by 12 is 30, and will always be 30. So he gives you this idea of a constant variable, which is a read-only variable. It gets declared right at runtime. You can never change it during runtime. And so the benefit of that is, first off, it's safety-proof. No one can mess with it. Secondly, it's a lighter memory footprint. So basically any variables that will never change during runtime, you can save a little bit of memory by making them constants, and that nobody can change them. So we know that we're going to mess around with the y rotation because we've already messed around with the game objects and figured out that's the correct axis for rotation. Now, so that's great. We can feed in x, y, and z rotations, get a quaternion that we know can be used for rotations, but we have to assign it to something. So in this case, we're going to take our hours transform, dot local rotation. We're not dealing with the parent's rotation, very easily dealing with the child's rotation, and saying set it equal to this. This hour multiplied by 30 degrees, put it into the y rotation. And now we have our hour hand pointing at 3, which is correct. So now we can do the same for minutes and seconds. His indent structure is a little off. I'll paste it in. Just clean up the code a little bit. So we have hours, minutes, seconds equal to date time dot now dot hour, minute, and second. So we didn't have created these variables yet. They will also be constants. And technically, the minutes and the seconds are going to be the same. We have 60 minutes in an hour, 60 seconds in a minute. So 360 divided by 60 is 6 degrees per change. So now instead of 30 degrees per change per hour, 12 hours, we have 6 degrees per change per minute or second. And we're going to feed those in, multiply them by whatever the hour, minute, and second information is. So if we click play, the clock should set itself to the current time, 3:32, and whatever the seconds are. Is everyone able to get there? Okay. So he basically just moves instead of declaring that data structure each time. So if I open this up here, we go and find this information 3 times over. So he's saying it's actually easier, a little bit of better footprint if we declare data structure of type date time and then set whatever now is into that data structure. And then we can just call that every time. So time.hour, time.minute, time.second. All right, we have one data structure that keeps track of our time, and we just keep referencing it. Now that happened, if I just take this method, duplicate it, and just call it update, we now can set the clock to the time right when we start, and we'll constantly update the clock. So now we have a working clock. So the next stage is a continuous clock feeding in the fractions, basically. We're just going to switch to a different data structure so that we can get fractions of a second, fractions of a minute, fractions of an hour. So we can actually see the hour hand. So technically 3:30, the hour hand should be kind of in between the 3 and the 4, moving towards 4. In the discrete structure, it's always staying on 3 all the way to 3:59. It's still going to be angled at 3. And the way that we've been trained to read clocks, you're thinking it's like, oh, it's 2:59. And only when it hits 3 will we have a huge move from 2 to 3 or whatever. So we're going to switch over to this continuous time or fraction. To me, I think it's more like talking about fractional time. So once we enter this public bool, which will allow us to switch back and forth between different methods of calculating the time, we're going to have these two methods, which is basically, just this. So basically, I'm going to duplicate. I thought I had my copy statement still as my awake method. So duplicate this a few times, call this update continuous, update discrete, and now the content of our update loop changes. You say if continuous, we're going to run update continuous, else update discrete. So either of these update methods will be determined if this bool is turned on or off. Right now the two methods are the same, so it's not really, you can click play and test, make sure that the clock works in either. So it's still running the same no matter how I click on this bool. But now we're going to get into, well, let's change how continuous works. So for this, we need a different time structure, time data structure. So in continuous here, instead of date time, the structure is of type time span, and we're calling now instead of .now time of day. And over here, it's not hour, minutes, and seconds anymore. It's total hours, total minutes, total seconds. So if I hover over it, the error that we're getting is you can't convert double to float. So we've been introduced to booleans, integers, floats, strings, more custom data structures like vector 3s and quaternions and game objects. A double is still a decimal number. It's just it's twice as big, it's twice as precise, it has a larger memory footprint. So for real-time simulations like this, we just deal with floats. They're lighter weight, use up less memory, and we don't need that precision. That precision is more for like scientific applications or something. So basically, we're going to cast it. So that's what this is right here. If we do rounded brackets and just say float, we're going to cast to a float. We're going from a double to a float. Basically, we're truncating half of those decimal places off and turning it into a float. So now we're multiplying a float by a float. We're good. No errors. You can also cast to ints. So you can, if you're casting from a double to a float, you're going to truncate off like half your decimal places. And then if you want to cast from a float to an int, you're basically truncating off all decimal places. So if you wish to round, you're going to have to use like math.f, round up, down, ceiling, floor. Because it'll just say if you have a float of like 3.75 and you cast it to an int, it's just going to cut off that 0.75. You're going to get a 3. So that covers all that. Oh, that's actually the end. All right, so if I save this out, click play. We're in continuous. Or no, sorry, we're in discrete. And now we're in continuous. So the smooth motion of the seconds, reading in fractions, not this whole change. Also note how the minute and the hour are now in an in-between state. So we're at 3:40. We're almost like 2/3 between 3 to 4. This is what you're normally used to reading in your clock formats. And the minute is at, I guess it's moving from 40 to 41, so it's a little off center. All right. All right, so we got like 10 minutes. Was there any questions? Building the clock. So let me wrap it up. So the clock is done, but it's currently not positioned to be in the camera. So if you just messed around with the rotation gizmo, you'd see that, oh, okay, it's X around -90 to face the camera. So I'll just put that in. We're facing the camera. He's way too big. I'll scale it down and position it. And so the relative position and scaling, the rotation, everything looks good. Later on, as I mess with this and try to make it interactive, I might find that it's too small, too big, what have you. But for now, the clock is positioned correctly. So, yeah.
So the clock's not a UI element, right? It's actually like something in the world.
Yes. I would call it a passive UI element at the moment. It provides information to the user, and I'm positioning it within the user interface, but right, it's a 3D object living in world space where the user interface is way up here and it's just cast into screen space. But together in screen space, at the end of the day, we're going to be in the monitor screen space. They're pieced together, and they look like they're part of the same.
And I was wondering why when you were adjusting the time of day, the clock was like changing shape. But I guess it makes sense.
Oh yeah, so the light.
Yeah.
Right. So I could put a different type of shader on it if you didn't want the clock to change. So for instance, I create another material, call it clock face, and just go to unlit color and you just pick whatever color you want. If I drag that on, double check, yeah, it's unlit. So the other parts of the clock haven't been updated, but you notice the white face isn't changing color. So if you wish it to be the user to interpret it more as part of your user interface, use the unlit shaders, and it will always be the same illumination, the same color. All right. So we got like 7 minutes. Let me. So the rest. So the videos for the week, I'm going to be going back and going through how I built these diagrams, the user interface, I'm sorry, the user flows, and I'm going to be moving into, I have to clean up my user interface. It's a mess, organize it, reduce it, continue working on the clock connecting. If I turn this one on and turn this one, turn that one off, turn this one on, I can turn off real-time connected and I can update the lighting. So right now, just the sun, I figured out I had to do a similar situation with the light source where I had to make it a parent-child situation, and I had to rotate it so that I figured out, okay, if it's midnight, the light should be pointing up, which basically means it's like on the other side of the world. And noon, it should be pointing down, so I had to figure out the math to make it move through that. I'll do that in the online videos. But that's why when I cycle through the 24-hour period, I'm getting a full rotation of our sun. Really, the Earth is rotating around the sun feeling. So that'll start covering the videos. I've got 3 weeks or so of videos. I have quite a bit I have to do to build this all out. You know where I'm going with this all. And I will, videotape myself creating the posting, and so you have all the information you need as you're building out your app. And remember that we've got 3 full weeks of work time now left for Sprint 2. Don't save it all to spring break. And I'm not going to talk about the light system anymore. So we are good. Unless you have questions, you can hang out. Otherwise, I will see you next week. I'll get the videos up.